Do we have one here? Let me pull it up. The NetFlow application is built into the iOS, but for the analysis tool, you have to pay for that, right? So we can see, for example, here's an example of a NetFlow analyzer. This is a third-party tool. There's many, many third-party tools that they take that NetFlow data and they incorporate it into the tool. So we can see which interfaces are the most active interfaces, which applications are the most active applications, which hosts are the most active hosts. You get the idea of what we're trying to collect here. Let me see if I can find the Cisco one. That's for a wireless LAN controller. Well, I mean, you guys get the idea. A lot of pretty graphs and a lot of pie charts, right? How this could be useful is if you're trying to troubleshoot applications in the network and trying to identify if there are applications that perhaps you don't want in your network that exist. There used to be an old school way of doing this. It was called NBAR. Anybody ever heard of NBAR? Stands for Network-Based Application Recognition. It was purely command line. It didn't have all the pretty pictures and graphs, but you can enable NBAR on your platform, right? And it's really simple to implement. Let me go into this router here real quick. It's actually a quick way of seeing what kind of traffic is running in your network. All right. So show IP interface brief. Oops. Let's go into gig 0030 gig 00255. Oops. And IP NBAR. And then I can just do protocol discovery. That's literally all I have to do to implement this this capture. So if I do IP NBAR protocol discovery, now what's happening is this router is monitoring traffic that goes through that interface. And I can do a show IP NBAR, and I can look at statistics. I can filter out different outputs. Let's do protocol. Oops. See if it, well, let's do statistics. That'll be quicker. I don't know if we'll see anything here yet because we're not, it takes 24 hours for it to actually collect information. But let me see if there's one I can run that would actually show me something. Let's do show, I believe show NBAR. No. Yeah, unfortunately, we're not going to be able to see. Maybe if I do a protocol discovery, I can see some stuff here. Oh, yeah, there we go. So you can see I'm already seeing SSH traffic. I'm seeing EIGRP traffic, NetBIOS, ICMP traffic, some syslog traffic, and so on. And NBAR actually has lots and lots of predefined applications. Right, lots of protocols are already included in that package. If the protocol isn't included in your NBAR package, it'll just fall under this unknown category. So unknown doesn't necessarily mean it's bad traffic. It just means that in this version of iOS, I wasn't able to identify that particular type of traffic. And the nice thing about this is it shows me packet counts, byte counts, 5-minute bit rate, 5-minute max bit rate. So it tells me what, how much bandwidth is being utilized by that particular application. And it only took me one command to enable that feature. If I go back into the interface and I do no IP NBAR protocol discovery, that'll turn off the feature. All right.
NBAR, you can use that on switches too?
On multi-layer switches you can, not layer 2 switches.
Because NetFlow doesn't work on the switch.
Right. Yeah, certain iOS doesn't support NetFlow either. NetFlow does essentially the same thing. Obviously, it's a little bit more robust because it's going to export the data to a repository where you can analyze that data with pretty graphs instead of trying to look at raw data and figure out what that represents in your environment. Only if it passes through that router, right? Because it's the statistics that are collected on that device.
So, like you were saying, you'd have to have something at the switch level in order to see activity going on at that subnet.
In the LAN, within the LAN, yes, within the LAN. With NBAR and NetFlow, we're only monitoring traffic flowing through a device, not to a device, right? Okay. So what defines a flow? In terms of networking, a flow is anything that, any type of PDU that relates to other PDUs. See, routers and switches tend to analyze data on a per frame or a per packet basis. They don't really correlate the processing of one packet to another packet. Routers don't say, oh, this packet belongs to this flow, so I'm going to go ahead and apply this policy to it. IPv6 has that capability, but not IPv4. So a flow, from a classification perspective, are packets that are related to each other. You know, based on source IP, destination IP, protocol, the things that you would expect to see. We can even look at higher level fields like sequence numbers and acknowledgement numbers as well. NetFlow typically doesn't operate at that level. It usually just simply compares packets to each other and says, okay, this packet has the same source and destination IP, same source and destination port, same protocol, so it must be related to the previous packet. And that becomes a flow in my environment. All right. We can capture up to 20 to 50 flow records. Flow records means anything related to a flow itself. We're not talking about 20 or 50 packets. We're talking about analyzing and monitoring up to 20 to 50 flows. When you think about it, there really shouldn't be that many at one time, right? Because we're analyzing, you know, common network flows, which most hosts are going to be generating the same type of network flow. All right. Now, it's not to say that we can't monitor the same type of flow for different entities. HTTP traffic, for example, would count as a single flow, but then we can identify individual hosts that are utilizing that HTTP flow. All right. Configuration management protocols, I think you guys pretty much have a pretty good idea what this involves. SSH over Telnet, HTTPS over HTTP, SNMP version 3 over SNMP. Very important concept. SNMP version 1, version 2 had some enhancements, but it didn't provide authentication or encryption. SNMP version 3 is the only network management protocol that provides the ability to encrypt data as well as authenticate, right? SNMP version 2 and version 1. Familiar with SNMP? Anybody? Okay. Simple network management protocol. We use tools like HP OpenView or Boole and Babbage or Tivoli or, right? What's Up Gold, et cetera, to manage our devices, right? SolarWinds, et cetera. In the original version of SNMP, the only authentication we had was public or private. And we used community strings to identify the credentials. So a community string was like a shared password, basically. If I wanted to have read-only access, that would be my read-only community string. And if I wanted to have read and write access, then I would use a read-write community string. Okay? However, with SNMP version 3, we've incorporated the use of not only authentication, true authentication based on username and password, but also encryption. All right. Obviously, you guys understand why we would use SSH over Telnet, HTTPS over HTTP, and so on. All right. In order to enable HTTPS instead of HTTP, we're going to use the IP HTTP secure-server command. take a look at this platform here. Let me reconnect. Have a 10-minute timeout on this thing. Show IP interface brief. So Cisco devices have HTTP servers built into them. So I can actually pull up a browser and I can go to my Cisco device and access that Cisco device directly through HTTP. All right, unless it's not enabled. HTTPS, I think I've already enabled secure server on this platform. Yep. So when I authenticate to this platform, it's not a great interface. It provides me, it doesn't give me a nice, pretty little GUI. In this case, it will because we actually have CCP configured on this platform. There is you'll notice that there is the URL here says CCP. CCP stands for Cisco Configuration Professional. Right? It's not tested on anymore, but it's a little GUI that allows us to access pretty much all the command line functions of the platform through a web browser. Right? I can set up interfaces, do static routing, and specify, do logging, diagnostics, etc. All of this application is doing is taking the clickable features that I see in the browser and executing commands on the router to report the information or return the information. All right. I've never seen the QR code thing pop up. That's pretty interesting. All right. It's kind of slow. But little dashboard kind of give us, the health of our platform, CPU utilization, and so on. A lot of people don't know that this actually exists and it's embedded into the platform, but it is. And all you have to do is go into the device. There's another one that's kind of replaced this. It's called SDM, Security Device Manager. And it's a little bit faster. Obviously, this is not very fast, and so on. But, all right. So there may be reasons why you'd want to access the platform. Obviously, the only difference between HTTP server and HTTP secure server is whether or not we're encrypting that data as we go back and forth between the platform. All right. All right. In order to facilitate connections with HTTPS or SSH, you have to generate your crypto keys. All right. You have to come into the platform and you have to generate your crypto keys. If I do a show run here real quick, you can see the key is listed here. Now this is the public key, self-signed certificate that was generated when I actually generated my certificate pair. That's a 2048-bit key. All right. If you do the math, I'm not going to do it, but each one of those blocks is how many bits? 308, 202, 2B. What is that? 4, 8, 12, 16, 32 bits each block. And then if you count the number of blocks and you multiply that, you get 2048 bits. Simple. All right. You can't export these keys, but you can regenerate them. I can come in here and I can say crypto key generate RSA modulus 2048, and it will generate or replace those keys. Okay. All right. It's not a problem. I mean, the keys are self-signed, so it's not like they become invalid at that point. But that's this is an example where the key is actually an RSA key that was installed using public key infrastructure. Right? It's still self-signed actually, but let me see if that command works on this iOS. As soon as it's done generating the key. There we go.
Regenerating the key, though, if you connect to that previous thing, and then the SSH input again, SSH will have that previous level. You actually can do a morning.
Right. So if I restart my, duplicate my session here, right, because I was already in an active session, it would have exchanged that key in real time. But yes, if I wasn't in an active session or somebody else joins later, they would have to download that new certificate. Let's do a show run. I don't think this works on this platform. Section PKI. Oops. Yeah, there it is. So crypto key, self-signed key, meaning that it just wasn't signed by a third party. We can install keys that are signed by third parties, but you have to manage those keys, right? Now, this is the public key. What's going to be generated in correspondence to this public key? A private key. Self-generated and hidden, not visible, because that's used for our authentication process. All right. SNMP version 3. SNMP makes use of these things called management information bases, which is a directory of, I guess you could say, a structure of management components that allow us to access the device and look at various components of that device. SNMP provides get functions, which we're pulling information from the device, and push functions or set operations, which means that we're pushing configurations or setting configurations on the device. All right. Trap messages are informations that we get from the device. So an SNMP trap is essentially just a message that gets sent from the device to our SNMP workstation or NAM, Network and Analysis or Monitoring Station. And an inform operation is when I'm pushing information to the device. There used to be a tool called Cisco Works, which was a network management platform that Cisco tried very hard to make work very well, but didn't do a very good job of it. All right. SNMP version 3 provides these things, and these are very important aspects when you're talking about pushing and pulling information from a Cisco device. You want to make sure that you're providing for authentication, message integrity, non-repudiation of origin, etc. Because you don't want somebody simply being able to push information to your device directly. All right. Here's a basic configuration of SNMP version 3. It's a little confusing, actually. Before we get into that, let me point out this, because you'll see this on the test as well. There are 3 ways that you can implement SNMP version 3. No auth means no encryption, no authentication. So that's open SNMP. Auth means authentication, but no encryption. Priv means encryption, but you cannot have, priv stands for privacy, but you cannot have encryption without also having authentication. So priv is both authentication and encryption. So no auth, no authentication, no encryption, auth, authentication without encryption, and priv, both authentication and encryption. Okay? These views that we see here, those are basically essentially the MIBs that are being utilized to manage this device. 136121 is one MIB, 136149 is another MIB. And then we have our authentication credentials. So we've created this SNMP server group that references the NMS group, okay? NMS group is the group of servers. We don't actually see that part of the configuration here. We're using SNMP version 3. We're using privilege mode, okay? Privilege meaning encryption and authentication. And then we can see the SNMP server user is NMS user, all right? NMS user is the actual username, all right? We're doing SHA, message integrity and authentication. For a privacy component, we're using AES 128. All right. Now, this is why it's a little confusing, because the way this syntax is written here, you can't tell the difference between what's a command and what's a variable that you're putting into the command. This is the authentication password that you're using. This is the authentication user that you're using. And this is the privacy password that you're using, the secret key that you're using. Okay? So, if you break it down, there are variables that you have to specify within that command to provide that authentication. All right? I wonder if we can, let's see if we can, now, yeah, I guess we can kind of see here a little bit better how it's broken down. This is another way that you can secure access to the management plane of your device as well. You can create these access control lists that provide authorization to specific subnets or specific IP addresses. What I've done is I've created an access list here, access list 99. I'm permitting the 172.16.99 subnet, and I'm permitting host 172.16.50.50. Standard access list, so it's based on source IP address. All right. Then I go into my VTY lines and I specify access class 99N, which says that if you're coming from the 172.16.99 subnet or you're coming from host 172.16.50.50, you're allowed to connect to the VTY lines with SSH or Telnet. All right. In addition, if you're coming in through the web page, if you're coming in through a web browser, you're allowed to access the management through the web browser for the same reason. If you're coming from 172.16.99 or coming from 172.16.50.50. This 99 here and the 99 here obviously represents or references the 99 access list. And you could do names as well. Doesn't have to be a numbered access list. All right. I'm allowing SNMP version 3. We're using authentication and encryption. That's the mode. All right. And I'm applying access list 99 to the SNMP access as well. Does that make sense? All right. Enable secret, we talked about in the CCNA class. Enable password, not recommended. Why? Because the passwords are sent are held in plain text in our configuration file. We obviously don't want our information stored in plain text. Even if I use the service password encryption, Wade, you didn't get the benefit of this discussion, but I'm sure you've seen this before. Service password encryption doesn't actually really encrypt the password. There are many web pages out there that you can take that encrypted string, this string right here, and simply paste it into the browser and it will give you the password. So the recommendation is to always use the secret option because that is an MD5 hash. Not only is it an MD5 hash, it's a salted hash. All right. Couple of recommendations, and I would suggest that you guys consider doing this as a best practice standard in your environment. Set the minimum password length for your passwords, number one, which by the way would apply to all passwords in the system, including username passwords, passwords for the VTY lines, passwords for your enable secret, and so on. But this is another option that you should consider implementing. You have to be careful with this though. All right. No service password recovery. What is the service password recovery? What is it used for?
When you forgot your password,
When you forgot your password,
you do password recovery.
you do a password recovery on the device by rebooting the device, breaking the boot sequence, changing the configuration register, rebooting the device so it bypasses the startup config. Then since you bypass the startup config, you have no authentication. Go into privilege mode, copy the start to the run, change your passwords because you're already in privilege mode, save your config, change the config register back. Make sense? Okay. Yeah. That's how you do it. I'll say it again. Reboot the device, break the boot sequence, it goes into ROM-on mode, change your configuration register so that there's a configuration register setting that you can set to bypass the startup config. Reboot the device again, Let it boot completely. It goes into the initial configuration dialog because it thinks there's no config. Get out of that, type enable, copy, start, run. Now you have your active configuration, or configure replace NVRAM run. And then change your passwords and you're good to go. All right. If you enable this feature, no service password recovery, if somebody executes the break sequence on the platform, it deletes the contents of the NVRAM. So it's not that you can't get into the device, but it ensures that somebody's not going to be able to get access to your startup config. Right? Now that could be bad, of course, because if I want to launch a denial of service attack against your device, I'll just reboot it and break the boot sequence and then your config is gone. But hopefully you have config resiliency configured, because that persistent file is still in flash and you have backups on TFTP or external source. So no service password recovery does not, well, I guess effectively it disallows the use of password recovery option. I mean, it still allows you to issue the break sequence. All right, if I come into my platform here, well, I'm not going to do it on this platform, but if I come into the platform and I type no service password recovery, it gives you a warning. It says, okay, the next time somebody tries to break the boot sequence, you're going to lose your startup config. All right. By the way, that is a feature that can only be disabled from the console as well. You can't disable that feature from command line. Banners, we know what banners are. I don't have to get into banners with you guys. Banners are important. All right? Okay.